Hi, everyone, and welcome to today's meetup. Today is part of Matt's myth-busting series, and he's unpacking the myth that organizations need perfect data before they can start adopting and integrating AI. For this discussion, Matt is joined by Achal Maribe. He is a data and AI executive with a track record of leading enterprise-wide data and AI transformation. He held a group executive role at Old Mutual, where he established the AI Center of Excellence, and now he is transitioning into a consulting role where he advises a diverse set of industries and organizations. Matt is joined by our very own Jay Pansel. Questions are always welcome. Please feel free to drop them in the chat or raise your hand. And yeah, the session is being recorded and it's available on our YouTube. So I'm going to hand over to Matt now and yeah, take it away.
Awesome. Thanks, Maddie. Welcome, everyone, and thanks for joining us. Today, we are busting myths again, as mentioned. A few weeks ago, we had 3 data scientists busting the myth that AI platforms are going to replace data scientists. We ended off by saying that we need data scientists, but we also need great AI platforms like ecosystem. Together, we're able to deliver enterprise-wide AI. Now, we get into the debate or the myth around AI needing perfect data. We actually put a poll out. If you were involved in voting for it, thank you. Out of the 6 myths we chose, it was the most popular. When Jay and I are visiting clients and chatting to them, the frequently asked question that we always get hit with is the big data question. So when you've got a myth and a challenge like data, we need to get 2 PhDs together like Kyle and Jay. By the way, I'm also a PhD. I'm a pretty happy dude. So the 3 of us are going to bust this myth. Gents, thanks for joining me. I'm going to start off really on the bare bones. We talk about perfect data. How would you define perfect? Jay, do you want to talk to us about perfect data?
Sure. Now I can give it a glimpse. I think for us there is no such a thing unless you generate data that can be used. So I think that the challenge with taking everything from existing operational systems, if you had to think of structured data and unstructured sources like web pages, Wikipedia, documents, minutes of meetings or contracts, you almost always end up with a diversity of inputs. So that means that in some contexts, perfect might just mean that I have a statistical sample big enough for a data science or an analytical decision. If I've got unstructured data and I need to prepare that data for a language model or a chat environment, then you almost always need to think about how much work will go into, to make it perfect for a user to be used. That perfect, is a tough question because I'm not sure there is such a thing. For us, this means that there are various kinds of inputs. And the output of data for us, perfect means that have I been able to collect enough evidence so that I can influence the rate of learning continuously? So can I impact the decision that needs to be taken in light of the model that I'm going to be using?
So I imagine in this group of people, most of us are probably leaning towards you don't need perfect data. But there is certainly a camp. And if I think about one of the ecosystem international clients at MGM, one of their enterprise architects was saying to me that they've gone through, I think they said 7 chief data officers in 4 years because they just are so annoyed with this person in their role for not getting them the perfect data. So this is a camp of thinking that we really need to get our data in tip-top shape. You and I go into organizations often and it's the story. Oh, no, we can't do this because of our data. Why do you think organizations are so hesitant to start AI projects because of data quality fears?
I think they haven't thought through the clear separation of the various ways in which you're going to be using it downstream in your case, or whatever the use case is that you're working on. If you think of it in 3 pillars, on the one end, we know that if I need to do data lookup and I need to go find, Matt's details, or I need to go find your current credit score on something about you that is going to be used downstream for some kind of impact on either your, let's say, your medical situation or a financial situation, then I need to really worry about how accurate and precise what I'm reading is going to be so that it can be utilized effectively downstream. So that's what I think people get stuck on. they think everything needs to be accurate and precise. But if I'm going to work on a probabilistic model where I want to predict the probability of you responding to a message or taking up a product, or if you are likely to churn or not, in most cases, if I'm an organization where I've collected a lot of evidence about my clients historically, the statistical sample that I need to make a model work doesn't have to take into account all of your priors. So that means you can get away with a lot less than what you would need. And if you know what perfect looks like, you can train it. And I think what often happens is data scientists might spend a disproportionate amount of time on trying to get all the data for models perfect, as long as your context is taken care of. So if I'm going to train a model that's going to predict, let's say in the medical fields or even in insurance, I want to create an insurance product for a male gender or a female gender because of certain medical conditions that you can diagnose within that particular lineage. That means that the data set needs to have context. And the context then needs to contain enough people of that gender who have shown to have, been diagnosed with that situation and the like. By the time you look at it statistically, especially in the analytical space, you can get away with a lot less than what you would need if it is something that's going to be about approximation. That means that you don't need perfect, and people often get stuck on that. The third area is the generative story. The generative story means that if I'm going to take my last 100 meetings that I've had in my company and I take all the minutes of meetings, or I take every single conversation that has been transcribed over the last year, I want to extract something meaningful. The amount of noise in there is enormous. So that means you actually don't want the accuracy. You want the noise to be present so that you understand where conversations went off the main track or where you've had various challenges. I think we often get stuck on the story without looking at the context. And that's why people often get so focused on it.
Yeah, makes sense. Obviously, you come from a large organization that has certain data challenges and have been hesitant to rush into certain AI projects. What do you think it's because of? Is it culture? Is it technical? Is it the quality of data? What do you think the fear is?
Yeah, I mean, I was just first going to start with just my background as well. I'm a trained statistician. So a lot of what we come in with is, we've got many data challenges, whether it's sensor truncated, you can't see everything, or you have some things, but they're not structured well enough or consistent. I think over time, we've engineered around these problems. How do you actually get an estimation with the fact that not all your data can be seen? Insurance is a pretty good example. We can't see everything. We don't know when a claim resolves how much it's actually going to be. And so there's a lot of estimation involved. I started working for Mutual, specifically looking at data management. So it's been interesting because data technology, quality, and governance were the core of what I do. We often find challenges with data, either because the source systems are not okay or whoever's creating the data is creating it incorrectly. But I think over time, it's been a culture issue where a lot of the leaders understand that you need to have amazing data to build all of these models. So I think it's something that's been perpetuated over time. But in fact, we do know, if you are estimating something, if your model or whatever it is that you're building is to be directionally correct, you can get by with just understanding and doing an exploration on the data that you have and trying to suss out for signal in the midst of all the noise. So I think it being a cultural issue, of course, there are more dimensions to it.
Yeah. Agreed. I want to dive into some actual real sort of examples. One of our clients is a large medical health insurance business. If you think about the health data space, the complexity and the systems, the specialists in the hospitals, and then trying to understand fraud. Jay will probably be able to delve quite nicely into that because of the work that was done at one of the clients. Surely then data does become a challenge. You've got all these different businesses, different systems, and different pieces of data in one procedure, if it is part of a procedure that we're looking at, and then extracting those and being able to understand the data out of that. I'll go to Jay first and then to you next. In the health insurance space, surely data must become a real challenge.
Yeah, I think that at the end of the day, it all depends on the context of the impact that you are expecting to create or manage once you've made a decision based on what you're using it for. If I need to get, let's say I need to do a procedure in a medical world and I want to go and do a claim against my insurance, I need to know if Matt was of a certain age and status within the product, signed off your forms around what kind of preconditions you might have, or if you've got any allergies. That always needs to be accurate and precise. That means you can't get away with that data not being correct ever. But what happens inevitably is that people keep recording it incorrectly, and there are systems issues along the way that then downstream, by the time it gets to the data scientist, the problem is amplified. And that's often happens. If I need to predict if you have a certain condition, if you take that as maybe one kind of case, I want to make sure that if I get a false positive, there's a certain set of subsequent actions, and if I get a false negative, because either way I need to know what the impact is going to be by misdiagnosing you. Because the moment I misdiagnose you and you take an action on it, how do I recover from that? Right. And what is the remedial action that's going to be taken later on? So that means that the data life cycle, let's say a medical example, is that if you record the person's personal details correctly and it gets captured wrong, let's say they get your birth year wrong and make you 20 years older or 20 years younger, the impact on the physician looking at the file, by the time it gets to your insurance, imagine they say you must do a procedure on the left leg, but you don't have a left leg, it was amputated years ago. And let's say you get to, so there are situations where in some industries, it's far more sensitive if you don't have access to accurate data, especially if your systems are problematic. In the context of banking, what happens is that, you get KYC, so that means that I get the documents from you that proves to me that you say who you are, and I might scan it in OCR, but I sit with the same problem because I might end up, getting certain details about, let's say, your address wrong or whatever it might be. And that means that by the time the data analysts look at this thing and they're trying to figure out how they're going to target people of a certain income groups, certain lifestyle, certain product, you might get it wrong. So I think that is something we pay a lot of attention to. If you deal with digital interactions, those are our favorite environments because you normally have evidence that is collected incredibly reliably, especially about when you signed up, how many times you've clicked something, when did you transfer money, when did you go do, if you, let's say a banking example, you've gone onto a medical app and you registered yourself for a certain procedure, whatever it is. It's the patient, person, or the client managing their data themselves, and you force them down a certain tunnel. So there are push and pulls.
100%.
If I could add, even in how you think about your data architecture for an insurance company, the first thing is know who I am. That is like, number one. So you get that wrong, like you and I are not going to get far as your customer. Then you want to know the information about me. Then you want to know people around me. Then you want to know my behavior so that you can anticipate my needs. So if you go down this funnel, there are crown jewels that you have to get right. I agree with you 100% that we had a case where we need to use a machine learning model to merge duplicate record or separate them. You need to understand the level of risk that you're willing to take, because merging a record means you're going to be contacting the same customer. One of them is incorrect. And then separating them as well, there are consequences to that. So there's some trade-offs. If you understand the level of risk, and if it were to happen, these are the contingent things that I would do, then you're in a better position to actually decide what's good, what's not. Over your data maturity lifespan, there are opportunities everywhere. It's about channeling the right use case to the right problem for that level of maturity.
Yeah, that's a great.
Definitely.
I was thinking we often have this conversation. Think about the customer journey. If I get it wrong, based on, let's say I've got a behavioral model and I get your personality type wrong, and I think you are intentional, but you're actually experiential. The consequence is inconsequential. Because I might have just spoken to you in a way that might be a bit too direct or too happy, but it's not something that will trigger an action to say, well, I'm very unhappy because this person doesn't know me. That's why I think that with our team at a recent event, I quite like the way they created the banner of the tagline, Dear, first name here, I can do the following for you. It's not, if you get the first name wrong, yeah, there are consequences, but it's not something that you have any legal implications on. But if you look at the opposite end of the process, and I'm busy driving a legal process because you haven't paid or something like that, and I've got the lawyers activated and I'm going to get involved legally, or I've figured out that I'm going to give you a mortgage on a loan and I got it entirely wrong.
Exactly.
Things are very different then. So that means the impact of the risk and the financial situation is very different than if you just have it in a context.
I think you also touched on it around various businesses and data coming from various systems. I think of another real life example. We work with quite a few loyalty customers. Loyalty, like AI, spans across multiple businesses and large organizations that have to share data. Let's use Old Mutual, for example. I might have a few of your products, but now you're introducing a banking partner and a fuel partner, a telco partner, and they also might have some of my details. This is a big space with lots of data. Do we apply the same sort of principles to this? Who owns the data? How do we get the best out of the data so that the AI solutions are actually, giving the best customer experience and delivering, let's stick with loyalty, a great program like Vitality or eBucks or one of the other loyalty programs. That understanding behavior, understanding that, you're wasting your time sending me McDonald's vouchers because I'm never going to use them. Do the same principles and theories apply here? Either of you can answer first, but please both answer.
Yeah, I'm inclined to say they do, going back to the example that Jay made around some of the things you don't necessarily want the most accurate answer. I'm thinking churn as an example, right? So the very first thing that we have to think about when you're thinking about customer churn is you will possibly not have certain variables. For example, if a customer leaves, just because at the time that you're modeling, they haven't come back, it doesn't mean they'll never come back. So that observation will not be fully realized. That's an example of data that's going to be incomplete. All you want to do is predict the likelihood of getting this customer back. Or sometimes all you want to do is predict, what is the customer churn that I can expect. So there are various such use cases that have tremendous value. You will find that you just need some signal and be directionally correct. So in other words, your model is more than 50% correct most of the time, or more. I know that's a low number for data scientists.
But you're raising a very interesting thing, and that's this. We have this debate endlessly, and especially in the world of static models. Matt, the way we look at this, and this, but let's just quickly think about it. If you're going to create a static model, and it's based on a long lineage of data or behaviors that you've exhibited, and I've got a lot of priors that I want to, in some form or another, extract evidence to make a prediction. It's quite different than in our world, what's known as a dynamic model. The dynamic model means that if I can reliably get data points from you while interacting with a call center agent or on your app or on your web interface, whatever your digital channel is, I can make decisions far quicker, and the prediction is about some variation of your behaviors. Yes. And then by the time I get to generative models, you sit with an entirely different challenge, because now if you wanted to fine tune a model and you take a base transformer that was created by Mistral or by Meta or some company out there, you by default don't have any understanding as to what the weights look like inside the model and whatever was used to create the base transformer. Now you fine tune it with your own data that you have gone through a preparation phase. So that means each of those present very different downstream data problems and prediction problems based on the risk you're willing to take. The risk for us is almost always a primary decisioning point, because if I'm going to, let's take the churn example again. What we often do with a churn case, and especially in the services sector, is we turn the churn case into a sales opportunity. So what does that mean? That means that instead of making a prediction and getting it wrong, and let's say I've got a false positive, and I offer you a big discount, or I offer you something that is, let's say, financially impactful to my business, it might come back and bite me later on. But if I turn, let's say, that same churn prediction, even if it's a false positive, I want to convince you that what you have is good. Let's take that as one of the strategies. That means that the campaigning and the downstream risk that I'm taking is reduced radically, because I will then say to Matt, listen, you do know that your offer, this bank account, this insurance product you got, is better than anybody else because of this related to accurate and precise data collected about you. So I can say that people of your age who behave like this is better for you. The prediction then tells me how to talk to you, and then I can act on it. In a dynamic model, the data that we've been working with, let's say it's a stream, and the moment, and let's say I take, let's take a kind of an arbitrary example. You want to let a model converge on the options that you select in an app continuously. You go to your banking app, and every time you've been into that app, you've only looked at, let's say, the balance of your credit card, and you go 3 levels down and you go pick that option. The next time you log in, you go 3 levels down, you pick that option. And the next time and the next time. How many times before the app should learn, oh, Matt does this in the mornings. But when he goes into the app at 1 o'clock, he pays a bill. That means a time level convergence in real-time dynamic interactions means that the priors that I'm taking into account and that I'm discounting over time, I'm not going to care what Matt did 2 years ago, 1 year ago, 2 months ago. It's a bit like a combination of the Netflix effect with the Spotify effect in your banking that we see a lot of people often forget. And that means the model convergence and the training and the priors are tiny. It's a micro model. We call those micro models. I can get a model that will take 20 of Matt's priors or 5 of your previous interactions, converge instantaneously, and then see if it creates a better experience for you. Anyway, did you get the picture? I think that for each of those model types, if you have an understanding of the risk, an understanding of the reliability of the prior, your data usage around how you're going to generate predictions significantly can shift attention.
Awesome. Let's jump into a little bit of more tooling and how we solve this. If we're saying, don't worry, you don't need perfect data, and we've got a greenfield project, we want to kick off a piece of work, we know that our data is not pretty. How do we use the tooling that we've got? How do we use the methods and approaches that we've got to give our customers the comfort that they can do this without perfect data? Either of you can go.
I mean, I guess that, the importance of fundamentals start to come in, knowing exactly what to use when. One thing I will say is, working at McKinsey, we had a structured approach to building out use cases. You have to identify, for this to work, what are the critical data elements that I need? Then you can start ranking them. These are primary data elements, these are critical data elements, and so forth. So the ones that you can do without and the ones that you can do without. And then you need to think about the entire system. How do I think about the integration? There are going to be a lot of things that I need to do to get these use cases out the way. And so feasibility becomes one thing, part of the data as well. And then the last thing becomes the impact, the actual impact. So there's no thing that's stopping you from exploring. I think, once we've been clear on what the problem is, we might not be able to solve all of it, but certain components of the problem. Just go in, look at the data, and when I say just go in, I mean exploratory data analysis, mean, average, variance, all of those things. Test the model, see if things work, or tell you anything. I think it's just about getting around the data paralysis to see if there's something here to actually work with, aligned to some value, because we also don't want to waste time focusing on things that are not going to yield anything. Yeah. So I'd say that would be my framework more than what sort of tooling you should use.
Okay.
It's a tooling angle, maybe, Matt. That might be
yes.
So here's the, I don't know, let's make up some language. The lazy data scientist quick out.
Yes.
What we do, and we do this even if we don't feel lazy about doing the pre-work, but we take an entire data set from, let's say, like in this example, you want to find what's important, what's not. And instead of doing principal component analysis and graph-based models initially on any of the data, we do none of that. What we do is create an auto-encoder and take whatever the data is. We don't remove any features, columns. We don't change anything. That means dirty, bad, good, missing, dates not correct, whatever it is, sits in the primary set that was sourced from the source system. At time +1, +2, +3, it's going to look like that. So that means it's a sense of reality. It doesn't matter how much you clean it. So then what we do is we run an auto-encoder. An auto-encoder is a recurrent neural net, a deep learning model that runs across every single data point. So now the question is this. we've run it even for smaller data sets. Let's say you've got 300, 400, 500 million rows or 1 billion rows. The model with a fair amount of compute can probably run for as long as 5 days. And that's right. I've run autoencoders many times that ran for more than 5 days. But you could run it on small sets that might run for a day. What is it worth to you while you do other things? It's kind of the way we think about it. So that means as we start, we throw it into the auto. Now, the result of the autoencoder is that if you think about what deep learning does compared to what classical, let's say, tree-based methods or even clustering-based methods are doing, is that it takes every single data point. We normally, and it starts comparing them with each other, and the back propagation gives you a score of the relevance of every single data point in the entire data set. And what happens is that if there are high degrees of similarity, let's say in time patterns or in behaviors or in categories that co-occur or in date ranges that normally co-occur with categories, those become visible almost instantaneously. Because what will happen when you look at the output and look at variable importances, and we take the variable importances of the top 100 variables or the top 100 data values across a data set, I've never seen a data set that doesn't have a long tail. It is almost like, we can almost call it the rule of autoencoders, that it creates this data set where you're going to find that with very little effort, from the beginning, you can get an understanding as to what bad and good looks like in a data set that you're looking at. So we've got like the hyperparameters that we then use is we then fold the model and make sure that the scores generated through the gradient descent are usable. We set the rate of learning to be fairly slow and the epochs to be typically between 10 and 20. I'm normally trying to overfit the model as much as I can, although it will never overfit because autoencoders will run for years before they overfit, depending on obviously the data set. But I found that that's been for us very, very effective in trying to understand, because then you can clearly see, like, and I'll give you a classical example in the recent data set. It's an insurance problem, and everybody had this assumption that, let's say, a certain excess or a certain gender or a certain type of person or a certain product will be very important. When we ran the autoencoder and reviewed the variables, it looked like it had to do with your date of birth. That had never occurred as even remotely in the context of, how you would think about the problem that we were solving as an important variable. And yet it immediately popped up in the autoencoder showing that across every possible correlation that it could find through the epochs, it kept on popping up as one of the most important variables. It's a bit like we found like in banking, and this is a funny one because I've run autoencoders in banks too many times. It's like, I think that's also what gave me some of my gray hairs of the hyperparameters. But we found that if you want to solve a churn problem in a bank, I can probably comfortably say that even if you ran no model and you had to take the relationship of the number of financial products that you have with me and when last you interacted with me, I'll be able to predict within 90% that you're going to churn or not. How's that for a kind of like a modern heuristic?
And this is before any engineering of any sorts.
The idea is that if you leave the data dirty, you have a real reflection of the real world. And immediately in the autoencoder, you will see that the variables that often sit on a long tail, most of it is mess. We often joke, how many people were born on the 1st of January, 1970? Now, let's say you take a distribution of your customer base and you see a spike of people who were born on that day. It's fishy, but when you look at it, you'll see that the Unix epoch date for default dates for missing values is the 1st of January, 1970. So that means when you then look at the autoencoder, you can clearly see some of these variables are popping up that you've seen before in your project, and you then go and investigate. It's like the lazy data scientist step 0, because you can use deep learning to go and extract the evidence that would have been for you almost impossible. You could have created 100 matrices and you still wouldn't have been able to find all the correlations. Where if you just get the model to run and you then start looking at the output, and then what we often do is we take pieces of data and rerun it. So you get a real reflection. Then I remove the noise, remove a certain category that I don't want to talk to, off a distribution, pick areas of the distribution of a particular variable, or pick a certain number of categories, and then train smaller autoencoders to find the importance within that context. And then the real work starts, because statistical stuff can play a far more relevant role because you've used an accelerated approach to pick your context.
Yeah, I really like that. And you mentioned something important there, that you want to use the raw data. I think it's something we often forget, that over-engineering features leads to over-engineering at inference. Just getting that real feel of how the data is coming in is important.
You can actually use the tooling to clean up the data. The more data you get in and use as your cold start to dynamic recommender, you can then marry up the data to say what is real, what is relevant, and what is completely irrelevant. Because depending on how long you've had the data for, we move on in life. I've gone through this with a spend personality. If I do the spend personality now, it'll tell you I'm industrious. I was never industrious. I was a spendthrift. If you look at my behavior, I'm very industrious. I've got a family now. I've moved on in life. I run a business. So that's changed. A lot of my data would be irrelevant.
But isn't that the thing, though? It depends on what you are looking for. If you want to understand, and if you think of how we break up, how we think about, okay, it's almost all human interactions in the system. If I want to get evidence of societal changes as people go through their biological age change over time, and if you think about banking, let's take banking again as an example. There are kind of two major discriminators. One is age and one is income. That's where it all starts.
Yeah.
Because you're either too young or too old to get certain products, and then everything else is sold under distribution when you're trying to get somebody into the credit window.
Yes.
Where if you've got no money, I treat you very differently than if you've got lots of money. So that means that your evolution of your life, when you go through, and here's another one that we found that popped out of a deep learning result, is when you get to divorce 1.0 and you shift from that situation to alimony 1.0 and you switch to Ferrari 1.0, you immediately sit with financial problems 10.0, because what happens is you start spending sporadically. You can almost see that the person was highly consistent for years. And the moment somebody goes through personal strife, the financials start showing evidence of that. That you can pick up their buying behaviors, their traveling behaviors, their asset acquisition behaviors, their switching their products, their insurance profile, everything starts shifting. So Matt, absolutely. I think time, for us is an enormously important thing. And that's why I think, imagine if you could do this. Here's kind of a vision. Imagine in your business, you take the last years of data and you want to train an auto-encoder that completes every single day of the year that started a year ago. So think of a moving window. So you build yourself an enormous GPU cluster, you spin up some capabilities on there, you take all of the data that you have available today, every transaction, interaction capability, and you run a model, an autoencoder with some parameters that will make it look a bit like a generative model, but you train it so that you can figure out if there are variable importances that have changed from yesterday. And then you start the next day, you start the next one with 1 more days of data, and the next one with 1 more days of data, and the next day with 1 more day. That means that as they start completing, let's say it takes 20 days to train a model with 10 days, then you start looking at, because then you'll have day plus 1 plus 2 plus 3, you start predicting the movements. And that's kind of what companies like Uber are doing. They run LSTMs, so it's a long-term, short-term memory, neural net across data to figure out when you go to the app that there's real time and that there's, predictions based on a societal shift to say that, yes, if I'm in the morning, asking, or searching for a car, it's likely I'm going to go to work or to the airport, but not to the restaurant. When I do it at noon, it's likely that I'm going to go to a very different destination than I do first thing in the morning typically, and it picks up those recurring patterns.
Should we pause to see if there's any questions from the audience?
There's a lot of comments in the chat, but no questions, mainly just
I
links.
want to touch on something that just triggered a thought, because, Jay, you and I recently at the Compliance South Africa event, we've been talking a lot around generative AI. Today we're talking about perfect data. Are we running into problems when we're generating data ourselves? Because everyone's running to tools like ChatGPT, we're generating what deems to be clever answers or clever information, and then using it, which we shouldn't be, because it's not governed, there's no guardrails. Are we sort of heading down, on the one side, we've got organizations going, oh, we want perfect data. On the other side, we're going, oh, let's make up all this data. Let's use a tool that makes up stories around a request we've put into it.
I think you got like 10 points in there. I'll just give a quick view and then I just think that that all analysts that I know at some point would want synthetic data to prove a point. You have a data set that was generated, and normally you generate it with a specific intent. I mean, how can I talk about it? Because you will set the size, a distribution, certain categories, you would set the parameters of what you want,
Yes,
the job to be done. And I think what has made the concept of generative useful more than almost anything else is that it is not a knowledge extraction tool. Nowhere in the latent space, by the time the model is encoded, does it contain the evidence of where the knowledge came from. You can train ChatGPT as much as you like while the current architecture of deep learning exists in its current state. You will never find exactly the reference where that source came from. And that's why, if you followed the legal profession recently, nobody has been able to legally sue ChatGPT for copyright. So you can ask it to speak like Stephen King. But the moment you ask it to quote something out of a book, it can't even get less than 1% of the words co-occurred in a correct way. That's the thing I think people miss about what the concept of generative actually means. That to make generative useful is to use agents that does the work that's accurate, precise, and its job is to generate. So if you use a generative tool to generate data, synthetic data, and you wanted to adhere to, let's say, the categories that you have in your business, your generative process needs to find your agents that will tell you what the valid categories are. You don't want it to make those up. It's a bit like you were saying, like the spent personality. If you ask GPT for spent personality 3 times over, it will give you 3 entirely different frameworks that sound plausible. Ours is empirical. What does that mean? We've implemented it with evidence, validating it continuously. That means I need to tell the generative tool, this is what an experiential or intentional customer is doing. This is what introversion and extroversion actually means in this context, and you must stick within those rules before you generate. I think that interface is not always well understood.
I agree with you, Jay, and I think simulation is important. We've been using synthetic data for a while. As a statistician, you need to test your model on something, but you need to know the parameters that went inside so that you can see if you can recover back, whatever the model can't see. Something to think about is, can you imagine what the first statistician must have felt like working with the data that he or she had to work with? It was probably nothing. So what we are now is we have actually too much data. I like the suggestions you made, Jay, because it means you can start uncovering and filtering out, what are the things that are not important, as opposed to we need more data. I think it's quite the inverse at this point.
I definitely want to mirror that point. I think that we hear this often. We need more data. We're not ready for this. We're not ready for that. And it's absolutely incorrect way of thinking. By the time we get too much data, most people just don't know what to do with it. And that's why we typically run these kind of models, like deep learning models, to go figure out, because you have this hyperdimensional problem that you sit with. It's the curse of dimensionality. You know what I mean? You got this.
Yes.
Yeah.
I know we're almost out of time. I think we certainly have busted the myth. I know there might be 1 or 2 questions, but is the audience convinced? Have we given you enough to feel that we've busted the myth around perfect data for AI?
I think that if I just look at some of the ones in the notes, somebody said that they use a bureau to clean data. I think that is definitely good practice anyway. A lot of companies do that. Using data management tooling companies to help out with services is always good, because you find that most of the data people we've been talking to specialize in that. A lot of them already use things like the workshops we run with them with deep learning models and so on to assist with finding where the challenges are. So I definitely think that is typically good practice. Somebody said something about the blockchain story. Blockchain is just a ledger, so that doesn't tell you anything about actually your data. It'll tell you where to go find it, but it doesn't contain all the data in the ledger itself. You can't have a blockchain that is terabytes in size. You've got a couple of K and then you're out of the block doing what it's supposed to do. So that's kind of an entirely different problem to solve, I believe. It's not really in our spectrum at all. And what is the last one? Continue only to use AI-generated models to feed. Yeah, I think that's an interesting one. If anybody's interested in AI models generating data for AI models, if you deal with a model that is using data that is linguistically useful, then absolutely you can use a generative model to generate the data. If you look at what's happened with Llama at Meta, it's worthwhile going to look at that. They had an extensive process to generate and clean that data to make sure it's linguistically plausible. So there was zero link back to the models trained inside a company like Meta. It might have personal data or certain personal details or names. So that means that synthetic data to get models to perform better is a practice. And that's then, unfortunately, push you back into this space that the purpose of a generative model is to generate output, not to do things statistically. It can't count, it can't do math, it can't do any of that stuff. You need to get tooling to do that. We don't believe for a second that your ability to take prior evidence and building models that are reliable and explainable are going to go away anytime soon. So.
Yeah.
Makes sense. A huge thank you to both of you. I think this has been an awesome discussion. Thanks for joining us.